we're going to move on to the roundtable discussion. So we are going to ask all the speakers to be on standby in case there are any questions. So let me turn it over to our HDF Group User Committee, Lena Pormal, Lori Kupler, Quincy Koziel, and Soren Abina. We do have a few ground rules here. If you do have questions, please raise your hand, or you could put it in the chat window and unmute when you are chose to speak.
Probably everyone is so tired. It was overwhelming amount of information.
Elena, maybe.
Yeah, but we could go throw provocative ideas out there and say, no, we're going to go make HDF10, new version.
Mark rose his hand. Mark, please go ahead.
Thank you. Can you hear me okay?
Yes.
Okay. So this goes back, I think, to Mike's very first set of slides on the business model. Slide 5 there had a number of activities, I think, that were aimed at providing revenue. And I was just kind of curious if it's practical, it may not be in this context, to talk about what the relative importance of those 3 areas that you cited, enterprise support, consulting, and KIDA work, are in terms of your total funding versus, for example, NRE contracts, for example, from places like, Livermore, Los Alamos, Argonne, NERSC, and so forth.
So Mike or Dex, would you like to take on this?
Yes, I can jump in on that. Actually, those contracts were kind of bundled in that second category, and they are absolutely critical. I would say about, let's see, I actually looked at the numbers about a month ago, and it was about 40% of our, more than 40%, close to 50% of our funding comes from those NRE contracts and related types of things. And one of the things that we are concerned about, and I know that the DOE labs are concerned about, is that the concentration of our funding from that sector. It's not, first of all, it's not fair to the DOE to have to provide, that amount, that percentage of our funding when HDF is used so widely all over the world. So we want to look for ways to extend that. DAX is working really hard to try to extend our reach into the private sector, as well as other government agencies. Enterprise support has grown quite a bit over the past few years and a couple of years, and we hope that we can really expand that going forward. But yeah, it's huge what you guys in the DOE provide in support for HDF. Does that answer the question?
Yeah, thanks, Mike.
Okay, thank you.
Any other reasons? Well, Mark, maybe you have second question. Your hand is
Elena, do you want to bring up the Google Doc and answer some of those questions? There are a few of the questions.
Might be a nice topic to work on.
Yeah. In the meanwhile, somebody else can come up with questions.
You mean Google Doc for the first talk?
Yeah.
Questions and answers one.
Let me share the screen just a second. I lost. Oh, okay. It's a long day. Share. I kind of started writing after my talk a few minutes. This is a long-standing request about recipes and examples. We have two examples just how to use particular HDF5 features, but we do not have really recipes, and this is something that I think we'll be concentrating next year, at least documenting what is available. There are some white papers that we start writing, and they will be available on our website. For example, we have a study on ECP applications like HAC, QMC PEG that describe the patterns and different performance, but maybe it's too big. So yeah, completely agree with this. We will try to, for second bullet, we definitely will try to make transition experience from our current documentation and our current website. It will be our third transition, so we learned a lot. We tried to make it smooth, but I would want to give you heads up. Our old documentation on that is not supported, which is in HTML format. It is served somewhere that we will not be providing that service anymore, so it will not be available. But we will disable it only when we have searchable documentation in Doxygen. About walls, tomorrow there will be a lot of talks on walls, and Quincy, I believe, will start with introduction on wall, and we'll discuss wall architecture. We're planning, right now we have repository of wall plugins on Bitbucket, and we will be moving those to GitHub. So we encourage everyone who creates wall, first talk to us, give us, or if you want to contribute to this repo, please do, because we will be testing production walls with our software. We'll add it to regression testing, and any help with documentation will be really nice. We will be holding few webinars on wall, like tutorial, and I hope at that time we'll create some material that can be distributed also with this repo. There are some lessons learned already from wall work that is ongoing now. Filter template code for new filter. Yes, it will be nice to have. So essentially filter function itself, if you look, there are a few examples. It's pretty simple, but most of the issues we have were with the callback functions and using of malloc and free functions that I mentioned in my talk. But this is noted. Python, I think we should collaborate more, and Thomas Luver will be giving talk on Python and H5Py. Internally, our group, as you saw, does a lot of work with Python, works with Python, develop with Python, and we try to contribute to H5Py, but this is kind of still goes on a sideways, so it will be good if our group has more bandwidth to participate, but we're in good contact with H5Py developers.
Hey, Elena.
Yes.
Mark Miller had a question.
Yes.
Oh, thanks, Elena. I didn't mean to interrupt you going through those if you wanted to, but I did have a question on the GDS virtual file driver, the work that and I'm sorry, I can't remember the speaker's name before, that spoke before John, but in the chat, Quincy and I exchanged a couple of questions and answers there, and there's a basic conceptual, well, two basic conceptual challenges that I'm having. And the first one is, if it's true that the GDS is smart enough, the GDS VFD is smart enough to do IO from CPU memory using the quote normal way, the section 2 way, and the IO from GPU memory using the CUDA way, why that particular thing, if it's smart enough to do that, why that just can't sort of become a standard unified VFD. effectively replacing Sec2. Quincy did argue that it make it much more complex with that if you start including HIPAA and other technologies. So I'd like someone to speak to that question. The other question is, I don't fully understand why GDS is 3x better than Sec2 at like 2 GB IO requests. Is it that GPU memory is 3x faster? Is it that GDS is doing, and the CUDA calls underneath it are doing, there's more parallelism going on? I just don't understand why it's fundamentally faster.
Answer the first one and lead up to John Ravi for the second one. So you guys hear me with this mic?
That mic. Can you hear me now?
Yep.
Yeah, we can hear you.
Lori, and we're saving chat, right? So we will be able to, thank you.
Quincy, are you speaking? We couldn't hear you.
Arguing with the system and sound and everything. Right. So,
you won.
Yeah, I won eventually. So I was going to say, I can answer the first question, or at least we can chat about it, and lead up to John answering the second one. But you know, I was trying. It's very low bandwidth to kind of type into the chat. It certainly is possible to like build more frameworks around the code inside the POSIX VFD, and then support the GDS extensions. But then we'd end up with everything kind of getting glopped together in a sense, right? But, you know, NVIDIA's extensions and AMD's extensions and Intel's extensions all built around, you know, the core set of POSIX calls, and invoking those, you know, kind of at configure time is certainly possible, but the code would get to be a maintenance pain. What I was suggesting in the chat was, well, maybe we should just stack a layer that intercepts whatever GPU you have in the system, NVIDIA for GDS or whatever, and handles the read and write operations at that first layer of the stack of VFDs, and anything else just gets passed down to the underlying layer for appropriate management with the POSIX one. Then we can keep all the GPU's buffer specific code outside of the POSIX one and still enable it on a configure basis at build time. It really is something we're going to have to iterate on. As soon as we have another system where we can have an example like NVIDIA and somebody else, then we can at least kind of play with the software engineering ideas. So don't know, but it is pretty early, and I agree with you. It's annoying to have two separate VFDs. So maybe John could answer closer to the why is this one faster. I think it's data transfer issues, but yeah.
Yeah, I can. I had a nice animation presentation that I had to cut out due to time. But basically, the idea is that when you do a CUDA mem copy and explicitly transfer the data from the host memory to the device memory, it actually instructs the copy engine on the GPU to go fetch the data from the CPU memory. With GDS, what's happening is that instead of using the GPU's copy engine, it actually instructs the NVMe's DMA controller to put the data inside the GPU. So the data transfer is like not being originated on the GPU. And for some reason, there's an extra overhead using the copy engine instead of DMA from the NVMe storage. NVIDIA wrote like a blog on this and shows like the overhead. It's like, I think instead of getting like 14 gigabytes per second, they get like a little bit higher using the NVMe. And not only like this is not only faster instead of using the copy engine, you can also get multiple data paths to put data onto a GPU at the same time, right? So like you can you can like instruct multiple NVMe storages to write into one GPU's memory at the same time. So you can get like much higher aggregate IO rates that way.
So John, thanks for that. I'm sorry, then I perhaps misunderstood your comparison study because what I was believing, what I was seeing there was a comparison of doing reads direct to GPU memory using GDS versus reads direct to CPU memory using the standard Sec2.
Oh, I see.
But
yeah,
it's not that. Is that correct?
That's right. Sorry. So the Sec2 case, it was actually copying the data from the storage to CPU memory and then to GPU. So there's like an extra copy.
Thank you.
There.
Now I understand. So the GDS effectively removes that overhead.
Exactly. Yeah.
Okay. Thank you.
I just added some comments to the document.
One thing, Mark, I was just thinking too, the abstraction layer that you were thinking about and, you know, avoiding another VFT idea will definitely happen when we offload the problem to the MPI implementations, because they're going to be the ones who have to figure out whatever's going on and write whatever handling they want. We'll just invoke the MPI IO VFT the way we always do, and they'll have to figure it out too. So that's kind of dodging the issue. We still have to deal with the issue for serial codes.
Okay, thanks, Quincy.
In the ECP project, we're also exploring other ways of doing this GPU I/O. Some of them include the asynchronous I/O and also having an abstraction that can deal with all GPUs, like NVIDIA, AMD, and Intel GPUs. So that is still kind of in the benchmark study right now. So in the next maybe 5-6 months, we can have more discussion on that.
Please go ahead with questions.
Okay, so this is Mark. I'm going to throw out another one. Maybe this is for you, Elena. The truth of the matter is, at the end of the day, for me, most of the code developers that I support and most of the high performance computing simulation workflows that I deal with are so strapped for resources and developing things that they really, I mean, they always talk about how significant performance is, how important performance is. We need to have better performance. But once they whack them all down on the performance front, for example, on I/O, and they're able to sort of set that fire aside, they don't go back and think about it for a really, really long time until performance starts biting them again. And so the general question I have for, I think, you know, all of us here, not just the panelists, but all of us here, is to what extent do people feel that performance can be, well, let me say it this way. To what extent can degradation of performance be accepted given the additional functionality that is made available by putting the data in an HDF5 container? There's a lot of really, I'll say this is my own opinion, really cool stuff that happens when data is put in an HDF5 container. It's in the broader HDF ecosystem. There are other HDF tools. There's a lot of really cool stuff that happens by doing that. And when people consider, quote, other technologies, and in particular use performance as the overriding reason for wanting to use those technologies, the challenge I have with that is ignoring all of that other cool stuff. And so I don't know, do people have thoughts on this? Do they end up routinely having to deal with it in their regular work lives, where people are saying, I just need to get to my data to disk. I don't want to be bothered with either the complexity of the HDF5 interface or or the performance losses I might suffer from it, but they end up shooting themselves in the foot because they generate several hundred terabytes of data that way, and then they can't really use, they have to develop a bunch of their own tools to really analyze it. So I'm just kind of curious what people's thoughts are on that. More of a I guess, a thought exercise than anything else.
We heard from at least 2 big customers of ours, and overhead that we have now of over 1.8 to 110, it's still too much for them. And we also have customers who didn't move from 1.6 to 1.8 and 110 because overhead of 1.6 over 1.8 over 1.6, even we have all those cool features, was really, they could not, their users could not tolerate, because those are you know, producers of tools. So for us, the lesson is that let's think about designing the features that we're not, when we add the feature, we're not penalizing users who do not use it. Is it possible to do every time? Jury is still out, right? But probably the answer is yes. But at this I will stop, because I just gave you 2 examples that we have real users who simply cannot move to new releases because of overhead we brought with the new features in the latest releases. And maybe someone in the audience will comment on this. And just as graphs show that I used, that not everyone even saw that, right? There are many applications that didn't see any improvement, even we added new features. It really depends on the patterns through the library and how library is used. So no one will comment on this? Mark, did I answer your question from our perspective?
Yeah, you did. I was just thinking as you were answering it, there are definitely, in my experience at Livermore Labs, probably a handful of cases where performance, negative performance results were really serious issues. So there's no question that it's an issue. But I would be willing to say that more often than not, people are unaware of how much performance loss, I'm putting that in air quotes a bit, they already suffer, but they are willing to accept because they're just basically either putting out other fires, they're distracted in some sense, or there's so much functionality that comes from what they're doing that to argue that they need, argue for performance reasons alone, that they need to push the technology aside and just sort of move to storage, just doesn't make sense for them. And so it's more often the case that people are actually unaware of how much better their performance could be than they're really aware of, wow, this performance is really bad.
So they're already in the ecosystem in a sense, right? They just aren't leveraging it to the best effect.
Well, there's that. There's 2 of them, I guess. There are some that either are not in the ecosystem, or even they are, and they're like going to get out. You know, like this is taking too much time, or it's too complex, or the files are too big. You're much bigger than I'm expecting, and fixing those problems is important for sure. Often there are problems that arise out of a lack of understanding of how to use the technology, maybe because of the level of complexity of doing that is involved. But then there are others that are thinking of coming up to the table. They're not in the ecosystem. They're going to try to use it, and they're like, oh wow, I heard performance of HDF5 isn't really great, so I'm not even going to bother with it. And again, it's this performance versus functionality thing. I don't know what else to call it, but I'll just say my opinion of this issue is, at the end of the day, throughout history in computing, people have always made the arguments for performance, but and if we were still doing those arguments that we were doing in the 60s, we'd still all be writing assembly code, you know, at the end of the day. There are all sorts of layers of software that got introduced to make developers' lives easy, and we pay for the performance cost because of what those things do for us. And this is just yet another example, but that's just my opinion.
Yeah, if there was a good recipe book with like real plots that said, without HDF5, with HDF5, here's your overhead, and then people could at least have a, you know, proof by existence that the performance can be fine. And if the use cases are close enough to theirs, then they should at least believe that their cases could be fine too.
Yeah, that's a great idea.
So any more questions? And document is live, so if you have anything, add to it. And
can you hear me?
Yes. Mm-hmm.
This is Randy. Hey, in regards to your last comment, which is because GPU traffic and latency, or even 9 nanoseconds, is very important to me. There's some bench groups at supercomputing conference. There's some groups in there that explore benchmarks, and I'm wondering if you have contemplated interacting, the HDF group interacting with these people that run these benchmarks at supercomputing conference. And if you want to follow up, I'll put my name in the chat.
Okay, so you're thinking like the IO500?
Oh, there's actually 2 days over 2.5 days of workshop all on benchmarking at supercomputing every year.
Yeah, sure.
And
Yeah. But IO related, the big one, of course, is the IO500. But that's like storage system level stuff. Middleware levels, I don't know there's much support for those.
Well, there's different aspects. It was just a thought.
No, it's very reasonable. Be cool. Maybe, Surin, you want to talk to the application benchmarking suite? That might be a sensible thing.
Yeah, so we have been working with various benchmarks that are somewhat representative of real supercomputing use cases. And Mark Miller, who is on this discussion, he has a benchmark called Maxio that represents a lot of the applications at Livermore and other labs. So to combine all these, we are coming up with a new benchmarking effort that takes a lot of these IO patterns into a single place and probably include even the Maxio, and then we provided that as a package. So we call it something called H5 bench. So it will be what we are targeting to release in the next few months. So the other aspect of it, we have worked on tuning IO performance on supercomputers for using various HDF5 benchmarks. So those are also available in a suite called PIOK, or Parallel IO Kernel Benchmark Suite. So if anybody is interested, I can point to them.
I just want to add that HPC is, I don't know if I can say in percentage, but I would say it is smaller part of our users. We have users on all over the systems, including Windows. And use cases that those applications have are very different from, maybe very different from access patterns for HPC applications. That's why it's really important for us that we have regression testing with different use cases. When we introduce our own new features, we test and have regression testing to see what effect of the feature has. And we started doing this work. So going forward, I hope it will be better. We will not have such, embarrassing episodes like going from 1.8 to 1.10 release. But as Mark noticed, complexity does and features do bring extra, and still I don't think we answered the question from Mark, and how much in general, how much overhead applications and users can tolerate. Is it 5%, 10%, or 30% will no one notice because no one measures, and performance is really not important. What is important, data is stored, data is organized, data can be shared.
Yeah.
Well, if I can share my perspective, performance, like I say, nanoseconds rather, matter to me, and this is for various visualization and virtualization applications in HPC scenarios. And as more and more deep learning algorithms come out and autoencoders are embedded in there as a means of feedback, I can say that the I/O is going to become even more important. And so it maybe hasn't been a concern because there's some other bigger pain points, but I can see this kind of percolating to the top as an opportunity. That's just my perspective. Like I say, where 10 nanoseconds is a huge difference to me.
Thank you.
I agree with you, Randy. I think previously with the simulations, what people were dumping the data was at some periodic time steps data was being written. So if the I/O was taking too long, they reduce the frequency of that or increase it where they dump the data. But with the I/O, the machine learning and AI applications, where it's all read intensive data, and people cannot tolerate that much overhead. So there have been some efforts in the past few years from NERSC and Oak Ridge National Laboratory, if you want to see them. And Livermore also has a new, the LBAN framework that is adding a lot of new I/O optimizations there too, which includes prefetching the data. So yeah, I think there are aspects of very high performance requirement applications, as well as some of the tools that can improve the productivity. So it's both, I think HDF5 is across all these spectrums. Okay, any more questions? Okay. Mm-hmm. Yeah, fully agree, Randy. Mark has a question. Is HDF5 library a file I/O library or something else?
I think the vol connectors change that.
Yeah.
Yeah.
No, and it's not only vol connectors change it. It was much more than I/O. It was data organization, data exchange, data portability, and really big data that can be stored as it started, right? So I/O was part of it, but HDF5 brings more. And now we're talking about that HDF5 really what is kind of left is data model and APIs, because storage can be anywhere, and it's not I/O in your old sense, I would say. It's, yeah, data goes, but where? It can go anywhere, to storage or to just other application and so on.
Yeah.
Yeah,
Thanks, Mark. I've actually tried that. It doesn't work because we try to read metadata.
You can put metadata to the
Right. So what's the craziest idea people would have for a vol connector? make HDF5 talk to what? We've got file formats, we've got data sources, we've got logging, we can stack them, we can talk to all kinds of stuff. There's a lot of potential there. And that really builds out the data model in interesting ways.
Mm-hmm. We have, yeah, better sensor systems. Mm-hmm.
Yeah, that would be cool.
Mm-hmm.
Some of the direction for the EOD work, I would imagine, too, like that.
Yeah, one of the things that we were discussing is remove the sense of just one file system and then add any file system or anything anywhere, even in the network, in the cloud, in the in a HPC site, across different file systems. So it is all over, the data is all over the place, but there is only one API talking to all those and having one sense of a file or container.
So circling back to Quincy's question about the craziest thing. So a question, this is, I think, a question for, you know, people at THG or who are certainly embedded with THG in some way. And that is, what is a better state of affairs for THG? To be pretty good at many things, or to be the industry leader at some things and not so much at others as a result? I mean, data storage is a big topical area, and I'll say that it feels at some level like we have a lot of breadth and capability, and that THG's approach to getting more, and I'll put in air quotes, market share, that's not the right word, I can't find the right phrase for that, is to maybe expand breadth. And I'll just ask, because I think it's a relevant question, is another way to go is to become, really, the technical experts in a fairly narrow area, and as a result of that, sacrifice breadth. And does that really align with THG's goals in some ways, if you were to do that? What are the cost benefits?
Mike, would you like to answer this?
Yeah, I'll give it a shot. I think it's a really profound question. It's a difficult question to address, and maybe I'm hitting it kind of at the wrong, not the angle, Mark, that you were interested in, but we don't want to be the world's best manufacturer of buggy whips. So I think we have to recognize that technologies move on, they change, and we have to be able to adapt to that. And in that sense, I think THG needs to grow and expand. But I don't think expansion for expansion's sake is a good idea. I think it's better that we're the best at what we do, and that we do it well. But for example, I think data services, just putting data in files, no matter how fast you do them or how much you do them, is I don't think that's all we can be about. I think we have to be about managing data more generally. I don't think we need to get into areas like visualization or analysis or some of those other areas. I think we need to do what we do best, but we also need to, the technology needs to evolve, and it needs to grow as the sort of surrounding technologies grow. And that actually, I think, takes us in a couple of different directions, and that is stressful. I think you kind of spoke to that, Mark. I mean, obviously the high performance computing world is growing and changing, and adapting to that is a really big challenge. But at the same time, you know, so many people, for instance, NASA, we see does not want to mess with files anymore. They want to move more and more to the cloud and be able to just think in terms of data services. And you know, they're an important part of our community. So I think we need to expand in that way as well. Other
But Mike, I would, yeah, I want to add, then I put that we kind of like that having few generalists, but go deep into things like we have with the resident HSDS, but it also necessity comes from nature of HDF5, because once again, it was from the beginning, not only IO library, it was much more than IO library. And if we look at NASA users, they need now to access data not only in cloud with the new missions, but all data. It's invaluable information that they need to analyze if they're doing climate. We see it's, and maybe not only in HDF5, but they would like to use few tools and not have many tools to access this data, because at the end of the day, it is about scientific research, and HDF5, if we need to do what facilitate that research and making workflows easier. And this is, I believe, perspective we're kind of taking and trying to balance where we're going. I don't know, Gert, maybe you would like to add something.
You know, Mark's perspective about embedded with PhD, you know, the group of developers we have in Lawrence Berkeley right now has a lot of focus by almost necessity on supercomputing solutions, right? So as THG is able to be more general, we can be more specific for that group and still contribute to a community. So maybe the future community looks more like a collection of groups working together, some with some more specialties and some with more generals in the longer run, rather than everything having to be a THG.
I certainly agree with that. And I think that's something that we haven't done as well, even as we could have in the past. But certainly looking towards the future, I think leveraging you know, people like Lawrence Berkeley and others where there's a lot of expertise is going to be tremendously valuable. And you know, speaking to Elena's comment, you know, I mean, for example, when we started, we didn't have people storing, you know, massive ontologies in HDF5, and now they're wanting to do that, and they really can't work with their other scientific data effectively without being able to do that. So that's another kind of area that I think we need to figure out how to accommodate in some way. And it's another area where we don't necessarily have to do it within the HDF group. There are other people who can do it and do it well. We need to, I think partnering, I think Quincy has a really good point, and I think partnering needs to be a major focus for us going forward.
Please raise your hand.
I will just mention I put links to the Google Doc on the agenda on our website. So if you think of something later and don't have it in the chat here, you can jump in there at any time.
Thank you, Lori.
We'll be back again tomorrow, right? So people add stuff there, and we can always talk to it tomorrow's talk.
Yeah, I just want to say thanks for all the technical talks today were great. Thanks so much for the effort in organizing that, and to the presenters. That very useful information to know about.
Thank you, Mark.
Thank you, Mark.
So hope next 2 days will be as exciting as first two. We had really excited tutorial yesterday. with all kind of bumps and bruises. So today was much smoother. So it was great. Thank you. Okay, then let's adjourn and see you tomorrow at 9 o'clock.
Okay, thank you.
Mm-hmm.
Bye.
Thank you. Bye-bye. Mm-hmm.